Now remember, our objectives was to not only be able to do one direction, which is if I have a dilation, lines are parallel, and I have the scale factor, but is also to prove whether it was a dilation or not. So as I look at this, I should be able to compare the image over the pre-image. And in each case, it should have the same value of r. And so it's given the diagram below, determine if triangle DEF is a scale drawing of triangle DGH. And so it's deceiving, but DG is actually this whole entire thing, which is 3.95, or 6.95, sorry. It's all the threes. And so when I'm making the comparison of this segment to the whole entire thing, it's say 3.2 over 6.95. The question really is that the same thing as this 5.9 over 11.9? Okay, so you can get out your calculator, or in truth, you could sort of do a little bit of estimation. 5.9 is really, really close to 6, and 11.9 is really, really close to 12, and so this should be approximately 2. If I do 2 times 3.2, I should get 6.4, and 6.4 is not the same as 6.95. And so ultimately, and I'll get you the exact decimals, so this should be close to 1/2. This is 0.46. And so these are not the ratio. And so what you can do in your explanation is explain the ratio of corresponding sides is not the same. Therefore, this is not a dilation. So keep in mind that just because they give you numbers doesn't mean they always work, so you have to check over and over and over again. The last one, it says, given in the diagram that you have 2 congruent angles, and you can see them here and here, so break out your highlighter if you want, and you're there and there. And what I noticed is that these are corresponding angles. And you can kind of think about this if I had extended this line out and this line out, and now you have your parallel lines cut by a transversal. If the corresponding angles are congruent, that implies parallel lines. Due to the like side splitter theorem, we know that if we have lines parallel, then we have sides in proportion. And so this is the real growth that when you start thinking geometrically or in these deductive logical ways, that's sort of how it's like an if-then followed by an if-then, and it's like one leads to the next, leads to the next. And so now I know that my sides are in proportion, and I can go through and I can find what I'm supposed to find. So it says find AB, so this is what I'm trying to find. There's my unknown. Now the trick to this is that you have the whole entire, so it's really like a part to whole, and you have to remember to write that 8 in there. And so if I'm thinking about this in terms of ratios, I can do CA over CF is supposed to be equal to AB over FE. Bringing out the numbers, I have 5 out of 8 is equal to X over 12. and I don't really like cross multiplication because kids mess it up so much. So if I multiply both sides by 8, that will make a 1 here. If I multiply both sides by 12, that makes a 1 there. And so over here I have 60 is equal to 8 times x. Divide both sides by 8. We'll get 7.5 is equal to x. And so that's how long AB is. And you want to make sure you've written that down. So AB is equal to 7.5 units. Okay, there's your video. Thank you for your time. Think about all the different ways you can put these together with ratios and proportions. Summarize before you turn your homework in tomorrow.